Here we are going to do a one sample z-test for mean in Excel via the p-value approach. So the scenario reads, researcher Franco claims that the average score of the Fundamentals of Statistics Math 121A is less than 85%. So to test his claim, he surveyed a sample of 35 of the Math 121A students. So we're going to use a significance level of alpha of 0.05, and we're going to use Excel and JASP in another video, but this video we're going to use Excel to help Franco complete the z-test for mean via p-value approach. The data is presented in the following table. Now we are going to transfer this data to Excel. So we are going to copy this column, Control C, Control V, copy this column, Control C, Control V, till when we copy all the 35 values. So all 35 values has been transferred to Excel. So we go to data and data analysis. If your Excel spreadsheet does not have data analysis, you go to file, you go to more, you go to options, you click on add-ins, and you click on go, and you tick analysis toolpack, solver add-in. Solver is for linear programming, but make sure it is tick analysis toolpack for VBA, and then VBA, and then you click OK, and data analysis will appear. You go to z-test, 2 samples for means, but we are doing a 1 sample z-test, so we need to create another variable. Let's call it score B, and give it a 0 value so that we can, kind of fool Excel in making it believe that we are doing a 2 sample, but it's a 1 sample we want. So then you click OK, and you indicate to Excel the range of the variable 1 from A2, and you drag to A36, and the range for variable 2 is from B1 to B2. Now you need the hypothesized mean, which of course we said is 85. One, we need the variance of both variables. Okay, so what we need to do now is to go back again, and we can actually calculate the variance of both variables. So we click here, then we go to formulas, insert function, and we go to statistical, and we look for variance of a population variance. Click on variance of the population, click OK, and we like the variance of these values from A2 to A36. Click OK, and we get a value of 141.72. The variance of variable B, that's our fixed variable, you just give it a very small variance so that we can make Excel believe that this is a genuine variable, and it will have very little impact, so we give it a small variance, 7 zeros. Then we go back to data analysis, z-test, 2 samples. Okay, the variable 1 input is there, variable 2, B1 to B2. The hypothesized mean is 85, and the variance of 1 is 141. B is very small. Let's add another 0. Make sure. Labels yes, because we started from A1, and our significance level is 0.05. And we click OK. And here's the output, giving us the sample mean. The sample mean is 84.857. All right, the sample of the 35 students, the sample mean of the score of the 35 students is 84.85. which is not very far from our hypothesized mean of 85. So that's why now we have a p-value, that's a one-tailed p-value of 0.47. Now we can recall that in the decision criteria for p-value approach, you reject the null if the p-value is less than the significance level, or you do not reject the null if the p-value is greater than the significance level. Now, when we need to conduct a z-test for mean, we need to convert the worded statement to symbolic form. It says, Franco claims that the average score of the math statistics math 121A is less than 85%. That's his claim. When we go to the symbol, less than is an HA symbol. This is the symbol for less than. And as we noted that the HO can carry equal all the way. Okay, so we're going to convert this worded statement to symbolic form. That will constitute our pair of hypotheses. H sub O, the mean, the population mean, because in the claim he's referring to the population mean, so we have to use the population mean symbol. And HO, we said it can be written as mu is equal to 85. And the HA now, it comes under the HO, or you can use H1. He said mean is less than 85. That's what he said. Now recall we got a p-value of 0.47, which is greater than 0.05. So we do not have to reject the null hypothesis, which is saying that the mean is equal to 85. And actually 84 and 85 are pretty close to each other. You can paste this in a text box, this output, Excel output. And our p-value of 0.47 is greater than the significance level of 0.05. So let us state this. So therefore, the null hypothesis is not rejected. You cannot reject the null hypothesis. In order to reject the null hypothesis, the p-value have to be less than alpha as stipulated in the steps. Reject the null if the p-value is less than a significance level. So now, since we have not rejected the null hypothesis, the null hypothesis itself is the conclusion, because in conclusion time it says if the null is rejected, if you reject the null, you cast away the null, then you are left with the alternative. The alternative statement is the conclusion. But if you did not reject the null, you kept it, then the null itself is the conclusion. So we have to conclude with the null statement that the mean is actually equal to 85%. So based on the data, always based on the data, that we are coming to this conclusion. The mean score of all the students in Math 1-to-1 A students is 85%. So that refutes what Franco is saying. He's saying it is less than 85%. Actually, the data is showing that it is actually equal to 85% because we will get it 84.8 from the sample of 35 students. Just take note, there's a type 2 error that could have been made because it says that a type 1 error occurs if the null is rejected, and it is true. But we did not reject the null. We kept the null. So a type 2 error can occur if the null is not rejected, and it is false because we only interviewed 35 students. What if we do another research and our sample size increased and we get a different set of numbers, a different mean, sample mean, then we can come to a different conclusion and we can reject the null statement. And actually the mean could be less than 85%. So please bear in mind there could be a type 2 error that could have been made, but it will only be known, reveal itself with another research. But for now, we are keeping it all based on our data that the mean is actually equal to 85%.